hard drive, then RAM. You allocate hard drive like space and then RAM. Now, when you allocate the RAM and you start your virtual machine, what happens is the VM automatically takes up the RAM you've allocated to it. So let's say you have a 4 GB RAM system, right? And you have a virtual machine and you allocate maybe 2 GB of RAM to the VM. The moment you power on that VM, the VM takes that 2 GB from the system, right? So the system is now left with 2 GB of RAM to work with, right? Now, that 2 GB of RAM taken by the VM, whether the VM is utilizing it or not, it's still taking that from the system, right? So you realize if you have a low spec machine, the system begins to slow down, right? Even your VM becomes slow. Now, Docker, on the other hand, runs a very low, what's it called? Version of the operating system. And funny enough, it uses the kernel, right? And all the resources of your machine. So let's say you spin up, or I'm going to slam this intentionally. So you spin up a container. I'll explain what a container is. So you can think of a container as a virtual machine, right? If you spin up a container, right, it doesn't take resources like the way the VMs usually do, right? So I said the VM will automatically take the RAM you've allocated to it. Now, the container, on the other hand, will just use the, what is it called? Share the RAM with the machine, right? So if the container isn't using the RAM, it doesn't touch it, right? As and when it needs it, it utilizes it, right? So it's just like running a program in your, like on your PC, right? Now, and another thing with the container, right, is the fact that it's very portable and we have like a repository where you can push your Docker images to. Like, I'll explain what an image is, right? So let's say I create a container, right? Let me explain what a container and an image is, right? So you can think of images as ISO files, right? If we are comparing Docker containers and then Docker containers and virtual machines, right? You can think of a Docker image, right, as an ISO file, right? Now, we install the ISO file and we get a VM, right? So in Docker 2, you process the image, right, which you can think of as an ISO file, and we get a container, right? So we can say a container is a running instance of the image, right? In virtual machine, we'll say a virtual machine is a running instance of probably an ISO file, right? Now, when running a container, right, we can actually do configurations and stuff in the container, then literally push that into a Docker Hub. So a Docker Hub is like a repository for Docker images, right? You can push it there, store it. The next time you pull it back up, you still have those configurations you've done there, right? That is basically what a Docker container is, right? Now, I'm going to be using it to pop the box I'm talking about. And so for people who have who utilize a very low like spec machines, you can actually utilize the Docker container I'm talking of. And I would love to share my screen to at least show you where you can get the Docker container, if I'm allowed to share.
Yeah.
Okay.
You can share. Are you having problem sharing?
Okay, no, I'm trying now. Just stop one. Yep. All right, can you see my screen?
Yeah, we can see your screen.
How do I hide this thing? Well,
It looks like you have to put it at the bottom.
all right,
Yeah,
all
that
right,
thing
all right,
is very annoying.
all right, all right. So, okay, so Docker runs on top of a Docker engine, right? And there are commands to interact with the Docker container. It's something, okay, it's not. All right. So, we use certain commands to interact with the Docker image and container, right? So I want to show you a couple of commands, right? So Docker images, right? List the images. That's when describing maybe using virtualization, I'll say the ISO files, right? So if I type Docker images, it lists them, right? So I have two images here, snipexe/blackbox, and then blackarch/linux/blackarch, right? Now this is the image you are going to be using, right? I hope nothing is obstructing my screen. I'm seeing there is something here. I don't know if you can all see.
Oh, it's not obstructing us, so we can see clearly.
Oh, you can see clearly. Okay. Right.
Yeah.
Now, I'm going to interact with the Docker image to create a container, right? That is a running instance of an image, right? So there are a couple of commands you can use. So it's Docker run, right? So we are literally saying we want to create a container out of an image. That's what the run command does, right? Now, -it is it's an argument for interactive mode. So I'm saying we want an interactive session with the container we are going to create, right? Because you can start a container without actually, you can start a container like a process, right? You don't need interactive access to with that, right? But here we need an interactive session. So we do -it. Now, I'm going to create a disposable container in the sense that it's going to be running, and the moment I exit out of it, it destroys. So everything in that container will just vanish, right? So I'll use the --rm flag, right? Now I specify the image I want. Now that's snipexe blackbox.latest. Now you specify what exactly you want to run. I want to run bin/zsh, right? And now ZSH here is the shell, right? The interactive shell I want. So if I press enter, right? Now I'm inside the Docker container. So I'll spin up a new terminal. Let me increase my font. Now, I want to show you I'm currently in a container, right? So if I do ls, right? You realize this, I'm currently in my home directory. So pwd shows you my home directory, right? You realize it's home/snipexe. But on my actual machine, this is my terminal. If I do pwd, my home directory is what? Home/snipexe. So this terminal session and this session are completely two different, what is it called? Environments, right? Now, a command to list the Docker container, because I currently have a Docker container running, right? So if I do docker ps-a, right? This is to list the Docker containers running, right? If I list, you realize I have, you realize, you realize I have two containers running, right? I have the by time session one, and whenever you create a disposable container, right? Docker names it randomly, like picks some words and then names it. So this is it. So you realize state was up 55 seconds ago. And this is what we just created. Now, I also want to show something I'll do later on, right? Now, to connect to a container, right? We already connected to the container, but you can like keep connecting to like the container. You can have the same instance of a container, yet you have multiple, let's say, terminal sessions, right? Now, to do that, I do Docker, right? Because the container is already running, right? I'm not creating a new container. I'm only connecting to an running one. I'll do Docker exec, right? There's IT for the interactive mode. Now, name of the container, that is what? Whatever that thing is, right? Then I specify the shell again. I can now do bin bash, right? There are multiple shells. I have bash there, I have ZSH, right? I usually prefer ZSH. Now, if I hit enter, I'm in that container. You realize I have, let me split this up. So I have two instances, right? So if I do touch, let me create a file here, right? To show you it's the same instance I'm running, right? I touch a file, ls, you realize it's here, right? And if I come here and do ls, you see the same thing here, right? Now, by default, the Docker container is isolated from your main operating system, i.e. the if it comes to networking, right, it's separate from your host system. Now in CTFs, you want to bridge that connection. So in virtual machine, what you do is you select bridge mode or something like a NAT mode, right, to get internet access. But by default here, we have internet access, but it will be NATed, right? So I'm pinging Google from the Docker container. Now, but any questions so far? If you have a question, kindly just interrupt me. I'll answer the question. Right. If I'm moving too fast, you kindly tell me. Right. Now, so this is NATed. Yeah, I'll exit this instance. So to exit from a Docker container, I just type exit. It will just exit from it. Right. So I'm closing this session and back to this session. Now, this is basically what the container is, right? So I'm currently in a running instance. Now, this was a disposable container. So if I exit from it here, right, and I do the Docker ps-a to list the containers running, you realize the one that was created is now gone, right? We only have the BT session. This is a container I'm already running, right? Now, if you want to create a persistent Docker container, we use the command similar to what we just ran. So run-it. Rather than --rm, we use --name, right? Then you name the container. So let's say hello world, right? Is the name you want to give to the container. Now, we specify the name of the image, that is knifesec.blackbox, then again, bin/zsh, right? Now, if I push enter, we are going to like have access to the Docker container, but I want to add one flag. Now that is the --network flag. Now, --network, you remember I said by default, we have something like a NAT network or an isolated network. But now we want to bridge the network, right? So when playing CTFs, you usually want to bridge because if you isolate the network and you connect to the VPN, the Docker container has no way of getting to the TAN interface, right? So if I do the --network and host flag, if I add that and push enter, now what happens is you see here, let me do this. So if I do, I have so many interfaces, but let me do dash. So I'm going to show my IP address here. This is my private IP, so there's nothing you can do to me. Now dash br-4-a, right? Now this, I'm connected to a Wi-Fi. So you realize that this IP address on my actual host is the same IP in the Docker container, right? Now, if I do ls to list the open port in the Docker container, you realize it's the same as when I do that. Sorry. When I do that, let me take away this on my actual machine, right? So networking is bridged, right? That's it. Now, that is basically what a container is, right? Now, we've created our containers.
Sorry
Any
to
question?
interrupt you.
Yeah.
Before you move on, there's a question in the chat for you.
All right.
Yeah. I think someone is asking about a particular flag. If what does that? Okay.
All right. Oh, okay. So in Windows, right? I'll use Windows because majority of people here use Windows. Now in Windows, to show or to view your IP address, right, for the various interfaces you have next, you do ipconfig, right? Now, in Linux, we used to do ifconfig, but this particular command is currently being deprecated. So the new command is ip, right? Then address, right? This is the command, IP address, right? So this command is going to show you all the NICs, right? I have a lot, so, but don't have a lot, right? So this command is going to show you a lot. So IP address, and if you want to specify a particular NIC, right? That is maybe you want to check out maybe just the WLAN, 0 interface. You do show WLAN 0, right? It shows you just that. So that command is just to show you the my NICs, right? Now, I did IP, right? It takes flag. So I did -4, right? -4 means just show me IPv4 addresses, right? Now -BR says that make it brief. You realize that for instance, I don't need to see my MAC addresses and stuff, right? So -BR makes sure that, oh, okay, it makes it brief. Then the A I just put there is just a short form of address, right? So it shows me a brief, what's it called, description of my NICs and my IP address, IPv4 addresses, right? I hope I've answered the question.
I think the person should be okay now. We can proceed.
All right. Okay. So what I'll do is start with the box, right? Now, I'm already running the container, right? For the box. So I'll just connect to that container, right? That was the container is also, because the container is already running, right? I'm going to do docker exec-it, then the name of the container, that's BT session, then bin/zsh, right? Now I'm in here. Now if I do IPA, okay, I'm not connected to the VPN, so let me do it. Now, a limitation of the container, right, is the fact that it doesn't have permission to create, think of it as a, how do I put this? Interfaces, right? Like virtual NICs, it doesn't have the rights to do that. So, and when you connect to the VPN using the VirtualBox using the OpenSSH client, like OpenVPN client, what happens is it creates a TAN interface, right? So you would expect me to do something like OpenVPN, then specify the name of my VPN file here. But this will fail because the Docker container doesn't have the permission to do that. It's part of the isolation process, right? So to connect to the VPN, I have to do that externally, that is on my host machine, right? So I'll connect to my VPN here. So it's in downloads. That's laptop, OpenVPN. So my password. Yeah. Okay. So I'm connected. So from my oh, I hope. Right. So from the Docker container, I can now do IPA, and you realize we have a TAN interface here, right? Because the network is bridged. So anything I do network-wise on my host machine, I can do in the Docker container, right? So first of all, let's open it here. So, okay. So we start by checking our IP address. That's the IP address of our target usage. And well, I have this thing. So let me do something real quick. I've already done the box. I want to move it to maybe DK usage. Right. So okay, CD. So from here, I have a function, right? It's part of the container. That's mkh, right? Now it takes some parameters. So if I do mkh, I specify the name of the box, right? So that's usage. Then I specify its IP address, right? Now, when using VMs, majority of the time, what you usually do is you have multiple instances of a terminal running because we can't use just one. We'll probably do Nmap scan in one, run maybe Go Buster in another, right? Now, I don't want the hassle of, what's it called? Opening this and typing docker exec-it to connect to the container, right? So I'm going to be using a terminal multiplexer. It allows you to think of it as a run multiple sessions of the same instance. So I will explain what it is. So mkh, the name of the box is usage. This is its IP address, right? Now I hit enter. Now this is what the terminal multiplexer is. So I have multiple instances of the same terminal within the session, right? I can create new terminal, right? Right, open new terminal, close them, so forth, right? Now, the reason why I did the MKH, specify the box's name and then the IP addresses, it automatically creates a folder with the name of the box. And then when I do IP, because I know I'll forget, I keep it in a variable called IP, right? Now I'll explain further what happens, what I'll use that for. Okay, so now let's start. So when you have a target, usually you want to enumerate for open ports, right? So scan for open ports. You're going to use nmap-sc-sv. I'll explain what the parameters are. Then now I'll have to put the IP address. So I'm going to use the variable I created, right? So percentage, the $IP, right? I'm going to use that. I'm going to store it in a directory called nmap. So the function, the MKH function creates the nmap directory. I'm going to name it initial, right? Now I'm going to add the --v flag, -vv flag, right? Now I'm also going to add T4. Now I'll explain what these parameters are. Now -sc tells nmap to run default script, right? We can run how do I say, very aggressive script, but now default scripts are not really intrusive, right? It's just going to probe for it's going to do light probes. Yeah, think of it like that. Now -sv is also going to probe for the service version of a particular service, should it find it, right? It's going to try to identify the service version. T4 has to do with speed, right? And this is going to be loud. In a normal production environment, you wouldn't want to do this. It's very loud, right? You literally be picked up by the Bluetooth. Now, I'll hit enter, right? Now the scan begins. Now we see there are two open ports, 80 and SSH 22. Now, for 22 is SSH. I wouldn't want to probe SSH now because I have no credentials, right? The attack surface for SSH is quite low, unless maybe we have some kernel level exploit which requires no authentication. But that is next to impossible now. You will literally not find that. Now, so we'll probe port 80, right? Okay, now you can run GUI applications within the Docker container. Let me do that. I know.
Okay, we have a question in the chat for you.
All right. Okay. Is a Docker black box contain all the tools and how can we choose it? I'll use them if we need to use. Oh, okay. So yes, it contains tools I usually use. So yeah, so nmap, and then, like I have nmap in here, in packet, Kerboot. Majority of the tools we usually use for CTFs. And let's say, what tool don't I have here? I can't think of any, but if you want to install a tool, okay, so the container runs Black Arch, right? Arch Linux. And the package manager uses the syntax is slightly different from Kali. Kali usually do apt install, right? Now, in Arch, you do pacman-sy. Because this is complicated, have an alias for that. So you just do install pkg. Oh, what? Oh, what? Yeah, so yeah, it's install pkg, right? Now you name the package. Let's say it's nmap, so you just do nmap. It's going to download and reinstall nmap. Right. That's how easy it is. If you want to search for a package, you can do search pkg. Right. Maybe you don't know the full name of the package, but I know a portion of it. So just do nmap. Let me make this big. Close the screen. Right. It's going to list almost every package with nmap inside it. So you can see Black Arch nmap here. Right. So you just do install pkg nmap, right? Now, and the reason I chose Black Arch and not Kali is the fact that when new tools come in, right? So when new tools are created, for instance, when Ferox Buster came in, it was added to the Black Arch repo, like, think of it as just weeks later when it came in. you don't have to go to GitHub to clone the tool. No, it's usually in what's it called? The Black Hat repo or the AUR. So it's very easy to install tools in Arch Linux. That's basically why I chose Arch Linux as the base operating system, right? So yeah, it contains all the tools. And then secondly, okay, so let me do something real quick. So this is, I'm going to Docker Hub. That is where Docker images are kept, right? Now, where the Docker images. So this is, I hope you can see my browser, right? Hello, I used to see the
we
browser.
can see.
Okay.
Yeah, we can
Yes.
see your browser.
All right. So Docker Hub is where Docker images are kept, right? And anybody at all can create an image and push here. So if you search for snipe.exe/blackbox, you find it here, right? It's over here. So if you install Docker on your machine, right, you can just do docker pull, right? Then snipe.exe blackbox latest. It will pull this. So if you search for maybe a Docker image you want, and you come to tags, it will show you the tag. So the snipe.exe/blackbox, then the tag here is latest. So Kali Linux also has an image here. Oh, did I butcher it? Kali, yeah. So they have their base OS here. It doesn't come with any tool, it's just blank. So you have to install your tools manually. Now, let's say the question you asked, so you want to install your tools in here. Maybe there might be tools you personally use that I don't. So you want to add them. All you do is, yes, spin up a container like I did. So Docker run, right? So you execute the container, but then you give it a name, right? So this is maybe temp, right? Then the name, so if you were using Kali, you just do the Kali thing, then maybe bin bash, you enter. Now, you come in and you do the not usual installation, the apt install, the name of your tool. You just install every tool you need in here. Then, now, even I don't have the instructions to save it in my head, but I'm sure I have it here. So let me black box. So I have documentation here. So I'm sure if you scroll down, there should be an option to so there's working with packages and function areas. Oh, okay, I don't have it here. But after this session, if you visit the Docker Hub snipe.exe/blackbox, I'll have documentation there on how to like commit Docker container, right? So you can actually save the container, convert it to an image, and then push it. That's literally how it's done. I'll add it to the documentation. Okay. I'm surprised it isn't here, right? But yeah, I'll add it to the documentation when I'm done. It's not complex, right? Let me go back here, right? Now, we realize we have port 22 and SS80, right? That's web server. Now, the Docker container actually allows you to run the GUI application. So I just installed Firefox and BebSuite in here. But should you pull from Docker Hub now, it won't be there, right? Because I for instance, run BebSuite on my local machine, right? Not in the container, but you can run it here. So if I do Firefox, right? Okay. So by default, a Docker container doesn't have access to your display server, right? Now, as in, so it doesn't know where to display the contents to. So what I'll do is, there's a command we use, right? So it's xauth, then list, right? It's going to give you, think of this as a authentication key, right? Then now you paste that here. You do add, then this, right? Enter. Now I've added this, so I can now do Firefox. Whoa, what is happening? Let me try something. Hey, the gods of demo aren't with me. Let's. All right, so let me do Excel. If it works out, it's me what I did. Whoa. This was working a second ago. So I require specified. Whoa. Okay, I think I have a problem here. All right. Well, I don't know why it's not working, but I'm sure I've broken something in this container, right? Now, because we do not have much time, I'll just use Burp Suite and Firefox for my main operating system. But I'll fix this later, right? So let's open Firefox and then access the IP. So let's go copy. Oh, all right. So there it is. Let's use this. Like, okay. Now, okay, I have done something here. So by default, right? By default, you won't have this entry. So forgive me, because I did the box, there are remnants here I have to take out to be able to explain further. All right. So by default, when you paste the IP address, right? Oh, this is crazy. This is oh, this is weird. So by default, when you paste the IP address, let me start a new Firefox install. Well, I'm actually surprised why it's routing, but by default, when you paste the IP address, right, your browser will try to reach the usage.hdb domain, right? Now, because this particular box, right, is on a different network, that is, we are connecting via VPN, right? Your browser doesn't know that, so it's going to forward this domain to the DNS service on the internet, and they will not be able to identify this usage.hdb. So what we do is, within the machine, right, we have a folder called the host file. Now, this, you can think of the host file as a local DNS, right? So what happens here is that your browser will first of all check the local DNS before reaching out to the internet. So if it checks here, it's going to see that there is an entry for that particular, that particular domain, which is usage.htb, right? So it's going to use this to do the routing, not the global DNS. Right? I hope that is clear. But as to why it's routing, I'm fully surprised. The gods of them aren't with me. So, all right. All right. So we visit port 80 and we have, we get a web interface. Now, what we usually do is, sorry. What we usually do is try to identify what the web application is used for, right? If we identify what the web app is like used for, its functionalities and stuff. So we see we have a login page, have a register and an admin page. All right. So, okay, let's go back. So we can access the login page. That's where we are. Register, we can access that too. Now there is admin. Now I realize the same thing happens here. Now, the browser is trying to reach admin.usage.hdb and then routing to sending this request to the global DNS. That's the internet. But we can only reach this from by connecting to or sending this particular request via our VPN. So edit our host file one more time. So edit our host file one more time. So sudo vim /etc/host. and then add that. So we are literally saying whenever you come across admin.usage.atb, send it to this IP address, right? Now, if we hit enter here, it should now work. All right. So here we also have what's it called? A login page, right? So let's go back to our normal login page. What we also like doing is Control U to view the page source, right? So you get to see the actual code, right, behind this beautiful interface, right? Now, in here, we sometimes find certain like comments that the developer left, or maybe certain things that aren't rendering here because of probably maybe certain JavaScript or parameters used. Oh, why can't I click here? Right. So if you look here, well, there is nothing interesting here. Well, there is actually nothing interesting here. Yeah. So we go back and continue probing. Oh, why can't I click? I just control it. All right. Now, because the login page, let's try logging in. Let's just enter anything at all. Right. Well, it's sending the request, but not giving us any error. Let's type some. Let's add a comma to test for SQL injection, right? Well, there's nothing. I'll want to start BEPSU to see exactly what is happening. Right now, BEPSU here is a proxy, right? Now, basically what proxies do is they intercept requests before that request reaches the server, right? So you can think of them as middlemen, right? So what we are going to do is send this request to the proxy, inspect it, then forward it to the server. So started the proxy. Let's go into proxy, intercept on, send this request. All right. No, this isn't it. Really? Okay, let me send it one more time. Admin at mail. So admin at mail.com and admin. Right. Okay. So this is the request. I'll send it over to Repeater. Repeater allows us to repeatedly send that request, like send it several times and then inspect it, right? Now, here I'll just forward. And I get /login. What else? No, it does a login, but well, it doesn't show any error or anything like that. I can't select Repeater. What is it? Or there is an invisible thing obstructing me from clicking Repeater, so I'll make it smaller than click Repeater. Back here. Now let's send this request with Repeater and see what happens. So, okay. I hope you can see the Repeater tab, right? Is it big enough?
Yes, please.
Yeah. Oh, okay. Okay. So we send the request, and what happens? It says it found the found, and then okay. So the request actually goes through, but then over here it redirects back to the home page, right? It redirects back to the home page, the login page. So nothing interesting happens here. So let's go back to our browser, stop our project. Right now, there is also a forget password here. Let's try that. So let's do admin.mail.com, right? Let's see if that one also works. Okay. So this particular functionality works, right? So it's telling us the email address does not match any record, right? Now, here, what we can actually deduce from here is the fact that this parameter we are passing in here, right, is being sent to the backend. The backend then requests for this email address from the database, right? So the backend is actually interacting with the database, right? Now, because we know this, we want to actually test to see if the application is vulnerable to SQL injection, right? That is a vulnerability, think of it as an attack that allows us to probe, how do I say it? The database, right? It allows us to make arbitrary requests to the database should this application be vulnerable. And what we usually do is just put in a single quote at the end of the parameter, right? So if I send this request, well, we get a server error. That is a bit of an indication that it's probably vulnerable to SQL injection, but it might not be. It might just be the backend just crashing, right? So what we can also do is we do an or 1 equals 1 dash dash dash, right? Now what we are doing, I'll explain this very soon. Should it work? Now, okay, I send a request and realize that now it says we have emailed your password recent link to admin / the whatever we provided. Now, this email is what we provided earlier on and it was wrong. So you might ask why it's correct, right? Now, let me open a text editor here and explain. So this is what a SQL query is, right? So a SQL query. So the query for this application might be something like select maybe email, right? From, and it's going to have a table, right? So a database table. So let's say the table's name is users tables, right? Then there will be an instruction where now email equals something like this. And we might have other instructions here. Now, in between this double quote is where whatever we provide is going to be inserted. So this here is going to be inserted here like this, right? So it's going to execute this statement, select email where email table from email tables where email equals this, right? Now, this instruction here will return true should it find the email address in the database, right? And return false if it doesn't, right? Now, you realize we put in the single quotes, and we typed all 1 equals 1, right? Then dash, dash, dash. Now, what happens is we manually inserted a single quote in here. Oh, Vim is going to mess it up. So let me clean this here. Right, we inserted a single quote here. The program already had, the program already had a single quote at the end. So we closed that single quote, right? And we added the or 1 equals 1, right? And did dash, dash, dash. Now, dash, dash, dash here is comment, right? So if we say comment, literally what happens is when you comment something, whatever comes after the comment isn't interpreted by, think of it as the interpreter, right? It's literally maybe you leaving comment for someone to read. So you are literally telling the program that do not read this as an instruction. Just think of it as a message to somebody, right? So everything after the comment isn't going to be executed. So if there was any check after this dash dash, it's not going to be executed, right? Now we put all 1 equals 1. Now 1 equals 1 is going to always be what? True, because 1 is equal to 1, right? Now the or operator behaves this way. When you have a statement and the statement is, no, let me even use this plain English, right? If I send someone and I say, buy me orange or tomatoes, right? If you go in and there is orange, you buy me the orange, right? If you go in and there isn't orange, obviously you what? Check if there is tomato and you get me the tomato. Now, whatever be the case, once there is one of, what is it called? The fruit, you buy it, right? So that's how the or operator works. Whether when you have so when this one returns true, right? It's not going to check this, right? and it will return what? True. Now, if this statement is false, it is because of the OR operator, it's going to check the next instruction, which is, sorry. It's going to check the next instruction, right? Because of the OR operator. And this, and this instruction here is going to return, and this instruction here is going to return what? True, right? So the statement in turn will be true. That's how come. I beg kindly excuse me for a second. All right, sorry, I'm back. Sorry. Now, that is why this statement was executed as like true, because we commented everything out and we had the OR 1 equals 1, right? So now we've currently deduced that this program is vulnerable to SQL injection. So we are going to pass this request, right, over to SQL map, right? And SQL map is a tool that automatically performs SQL injection for us. So over to SQL map. Let's, where is my, I have so many terminals now. I'm confused as to which one I'm using. Yeah, let me close it. Yeah, here. So we want to pass this that particular request over to SQL map. So we spin up our proxy again. This time we intercept the request and let's send a normal thing. So send, right? So this is the request. Now I'm going to save the request as a file. So just right click the request and then copy to file, right? Now, okay, one thing I also didn't talk about is the fact that you can actually share folders on your system with the Docker container. So I've shared this folder. So it's Docker shared, then add the box. Yeah, now doing usage, right? So I'm going to name it forget.request, right? This is a folder on my machine, but it's shared with the Docker container. So if I come back here and I do ls, you should see that request here, right? Now, the argument for SQL map is SQL map, okay, intelligence is already helping. SQL map, right? Then we specify the name of the file. Now, SQL map doesn't, whenever I specify, let's say, just request as the file name, although it's in here, let's say the name of the file is forget.request, right? SQL map throws an error, so it needs the entire path. So I'm going to specify the entire path to it, add the box, right? .usage.forget.this, right? Now, SQL map takes in parameters, right? Now I'm going to specify the -- level parameter and the -- risk parameter, right? This is basically to help, like, telling SQL map that, hey, go fast, go loud, we do not care about anything, right? Right, then we add a -- batch. -- batch tells SQL map that any question you ask me, just pick the, what is it called, the default, like, parameter. So it maybe asks a question like continuous SQL map. It's automatically going to pick yes. That's what a -- batch flag means, right? And then next, I'm going to at least help SQL map in identifying the particular field that is vulnerable to SQL injection. That's the --email parameter. So back to the proxy, this here is what's vulnerable to SQL injection. So I'm going to help SQL map with that. Else it will take a very long time, but I will figure it out even if I don't provide it, right? Now, --dbs tells SQL map to identify the database, the particular the databases within that database, right? The database is within that database. Now, if I hit enter, SQL map should start its enumeration process. Now, this thing is going to take a really long time. So, it's going to take a really long time. So I already ran it and captured my item now. So I'll show that, else we'll be here for the whole day. It takes almost an hour to finish this particular request. So I'm going to cut usage login in. So I'm going to show, I captured the old terminal the first time I ran it. So this is it. Yeah. So it starts from here, right? So this is the request I just used. So I used SQL, sorry, go back. So a SQL map dash, what I just typed, the level, the risk, the batch. I specified threads. Threads is also a way to tell SQL map that, hey, go fast, send multiple requests. Like it will go very, very fast. But if I still provide this, it will take a very long time. That's why I ran it and recorded its output, right? So it will run, and then down the line is going to output the databases, right? Now, the databases is listed as information schema and performance schema. These two databases are default databases, right? Now, this here is a database that was created, and that is what we are at least interested in. So we'll tell SQL map to also enumerate that database and then show us its table. So the flags are level, risk, the same thing. But here we specify capital D for the database, right? In question, that is usage block, right? Then dash tables, right? Meaning at least enumerate the tables, right? So it will also take time to run. So this is the output. Then it finally dumps the tables, right? Now, if we look through these tables, the interesting table here will be admin users, right? Because the other ones will not be of great value, right? So admin user sounds interesting because at least I want, if I get the admin's credential, I like that, right? We would love that. So we'll tell SQL map to now enumerate that database with specifying the table and then now listing all the columns available, right? Now we could have just asked SQL map to dump the database here, but this particular SQL vulnerability is a little bit complex and very, very slow. So dumping the actual database would have taken days. So I want to see the columns and then specify which columns I want, right? So SQL map is going to continue, and then now it will dump the columns, right? So it has the name column, avatar, created at ID, password, and then so on and so forth. Now, I'm only interested in the name column and the password, right? The name and the password. Would have also been, the username would have also been interesting, but well, I didn't see that. So I specified the same thing. Here I specified a table. Now capital C to specify the columns, right? Then dash dump, meaning dump the whole thing. Now SQL map runs, and then finally what? Dumps the name and the password. So the username is administrator, and then the password is hashed over here. So what we do is copy this hash and then try to crack it, right? Now, there is hashcat in here. The Docker container has hashcat in here. So I'm going to just create a file called hashes, put the hash in here, then save it. Then now ask hashcat to at least try to crack it. Now I'm going to be using a word list, the RockU word list, so RockU password, big database, RockU.txt, right? So at least brute force the password, all right? So in here, SQL map is asking for its auto detection mechanism is actually detecting multiple versions of like the hash. So it needs me to at least prompt it to identify which particular one it should crack. So I'll use hash. The first mode, that is the particular hash we have in here, right? So run. Now it will go in and in about 10 minutes crack it. But because I've already done it and cracked it, it just needs me to provide a show flag. Oh, sorry. Show flag. And the password we have here is what? Whatever one. Let's see. So I'll just copy this. Whatever one, right? Now that we have this credential, the next question is where do we log in, right? Now back to the web application, we realize we had an admin page here. It's taking its sweet time. Oh, okay, my proxy is still on, forgive me. So admin, we will do the admin. Let's try administrator. Then the password was whatever one. There's not much. I'm coming. Let me try this. Whatever one. All right. So if we had dumped the username, we would have realized it was admin, right? Now we use that credential and we finally get access to the portal. Now, if we inspect the code, we realize it is Laravel, the administrator portal for Laravel. Somewhere Laravel, right? Yeah, so it's Laravel admin. Right. Now, with that in mind, we want to at least go through here and then all right. We want to go through here and then find out maybe sensitive information or whether it's leaking any information we can use, right? Now, in here, what happens here is if we scroll, take it to right there. Okay, close. There. If we scroll down here, we see over here we have it's leaking the particular version of Laravel admin. So what we'll do is search online to see if there is any public exploit for that, right? Whenever we see version, we always want to check if there are public exploits for available, right? So let's go again here. So we search for Laravel admin, right? 1.8.17, that's the particular version we have, then exploit. Right. Now, you see there are multiple, how do I say, links in here for possible exploits, right? So we click on any, so we can, oh, what? Just invisible thing. Yeah. So, okay, we are seeing unrestricted file upload, right? Now, this is an exploit, but I'm actually interested in where that vulnerability is, and this doesn't like show that. So I'll move to the next one because okay. Now this GitHub page shows the particular CV for the vulnerability, and then at least gives us a link to resources. I'll love the NVD database because, well, because of their reputation, right? Now, in here, we go down and we realize, okay, we have at least an article down here explaining the exploit, right? Or the exploit chain. So we click, and now this particular article here shows you every step to take to exploit that vulnerability, right? You can see here, this is the same interface we have here, right? Now, this invisible thing again. Right. Now, so to exploit this, we're just going to go straight. But if you read the article, it tells you the exploit is in the file upload vulnerability, right? Over here. So if we come in here, right, what the vulnerability actually is the fact that you can actually upload PHP files and then get remote code execution, right? So although we upload maybe a JPEG file, we can intercept and later change it to a PHP extension, and that's going to execute PHP code, right? So back here, back to the terminal. I'm going to copy PHP reverse shell payload here. It's already in here. So I just do CP user share web shells, right? It's already there. So that's the part. Then I'm going to name it rev.jpeg, right? So ls, you realize we have it here, right? That's PHP code. So I'll open that. All right, delete the comments. And then here we can change the IP address in here to our IP address, right? Now, my IP address is over here. So I'll do this 10.10.14.50, right? Now change the port to something like 4444, right? The particular port we are going to be listening on, right? Now, this reverse shell is going to connect back to it. That's how come we are providing our IP address, right? And the port you are going to be listening on. So that's 4444. So I'll save this. And then in here, now, ZSH plays like it's, when getting a reverse shell is like, it's quite buggy. I'm sure there's a problem in here. So I'll use the bash shell for this particular purpose, right? So I'll use the bash shell, start a listener, right? Start a listener, that's using netcat, right? So now in here, we open port 4444 on our machine to receive connection. So if I do ss-tu TLPN, you realize on our machine we have port 444 listen, right? Now, let's upload the file now. So we browse, it's in usage, then rev.jpg. And now we are going to turn our proxy back on and intercept the request because we have to manipulate it a little bit. So let me just start the proxy and then now send the request. Right? All right. Someone might, okay, gone down. All right. So this, so if you actually read the article, right? It tells us that if we change the file name, right, parameter to PHP, we actually get it to execute the PHP code we put in there, right? So back to the proxy, we're going to add the .php extension here, right? And then send the request. Right now. All right, so I'm checking if we have our shell, but nope, we don't. So let's go back to the application and then refresh. Disable, refresh. All right, so the upload didn't go through, so I'll try one more time. So back here, browse, rev.jpg, right? Submit, change the extension to the PHP, then forward the request. Right. Now I forwarded all requests. Now back here, we see we've actually got a shell. Right. So if I do ID, I'm dash. Who am I? All right. So I'm dash. Now now that I have a shell, I'm going to stabilize the shell, right? If I don't, when I press Ctrl+C, I'm going to lose the shell. But if I stabilize it and I press Ctrl+C, I don't lose it and I get the up and down functionality. So I'm going to do Python 3 dash. So first of all, we usually check if we have Python here. There are multiple ways to stabilize the shell, but well, using Python is the most common, right? So we have Python here. So I'm going to do Python 3-c, then import pty.spawn. So it is a method to stabilize shells, right? So if I do this, now we have the prompt, right? So I can now do Ctrl+Z out of it, stty_raw-echo. Right, then foreground, reset. Right, enter. Whoa, I think I've broken something. Well, I think I've broken something, but the shell is still working, so I want to wait. What is happening? Well, I have some gibberish appearing. Okay, so I'm going to end this shell and then get another one because this here is terminate. Let me get so bash mcln ppm 1 right. So back here, let's refresh the application. Right now, let's re-upload the shell because I have no idea why that shell is buggy. So turn on proxy, send, change the extension to PHP, forward everything. Now turn off it doesn't. Right, so let's do it again. So -c import pty.spawn /bin/bash. Right, so control Z sty raw -echo. Right, so foreground reset. All right, it seems it's now working. Right, now I want my syntax highlighting, so I'll export terminal to Xterm. So now if I do ls, I have my at least colors in here. Now that we are here, we know we are the user dash, so we want to at least visit Dash's home directory. So CD automatically takes us to his directory. So if I do pwd, we realize we are in Dash's home directory. Right now, we do not know the credentials for Dash. So if I do sudo -l, it's going to request for password, which I don't have. So we can skip this and then at least list the contents of the home directory, right? That's ls-la. Now here, you have the users.txt flag, so you can submit to hack the box if you want. Now, there are quite some interesting files in here. We have the .ssh keys. So here we can, for persistence, what we can do is just upload our public key in here. So when we are SSHing in, we do not need to provide credentials, right? But the thing here, yeah, so we do not, because we do not know the password, that would be a very good mechanism for persistence. Now, there is an interesting file here that's an executable, that is the .mont.rc, right? So let's at least cut to see what it is. So we read it and realize, well, it looks like it's running some sort of a daemon on port 2812 on localhost, that is the machine itself. And we get credentials in here, right? So credentials with admin. So I'll copy this, right? And then, well, it looks like it's some sort of a monitoring tool. Now, it was running on 2812. So if I do ss-tlpn to list the open ports, the shell is quite slow. Okay. You realize here there's actually a service running. Sorry. So I'll at least want to curl to see what it is. So I can curl. So curl is a utility that allows us to make like basic HTTP requests, right? So now on port 2812. I realize, well, it looks like it's running something like a web server, and it needs authentication. Now, I've already probed it and realized I know it's a rabbit hole, but we can, but because of time, I'm going to skip this, but we could access this we could do a reverse proxy to expose this particular port on our machine, then access it via a browser to see exactly what it was, right? Then use the credentials. Now, whenever we get credentials, right, in a penetration test, what we usually want to do is password we use to see if other people have actually used the same password, or whoever created this file, the month.la file. Here it says that it was Dash that created it, right? But it could have been anybody that gave the code to Dash to also, like, and he created the file. So here, to list the users on the box, we can just do, we can grep for sh, right? I'll explain why sh. Then the etc parswd file. So in Windows, this file contains a list of users and sometimes services, and how do I say, their user ID and group ID. So over here we see we have the user Dash and we have the Xander, right? Now, I grep for sh because usually the users that have users usually have shell access, right? So if a user has shell access, it probably means at least we can probably SSH or switch to that user. So for instance, over here, we see we have the shell for this particular user, Dash is bin/bash, and the shell for Xander is also bin/bash. Right now, other services do not have then these the shells, so you can't actually like use them interactively, right? So because SSH is running on the box, we'll at least try to see if the credentials we got, we can actually, maybe we can use it to SSH into Xander. So we do this, then because the SSH server is running on the host itself, we can just do localhost, right? So we are SSHing into Xander from localhost, and then we are also connecting to localhost because that is the server the SSH client is running on. If it was maybe an external server, I would have specified the IP address rather than localhost. So we can actually specify the loopback address to 070.0.1, right? Now, yes, then we paste the credentials we copied. Now, Tmax, the terminal multiplexer I'm using, has an option. So it has an internal clipboard, right? So this is the credentials we copied. So I can just press enter, and it's going to paste that credential. So if I just do that again and paste it here, you realize it pastes the credential here, right? So now we try the credentials and we are finally able to access Xander, right? So we also do ls-. So we are currently, where are we? We are currently in Xander's home directory. Let's also try the ls-la, right? Realize, okay, there are certain files in here, folders in here, cache config, but so in a normal circumstance, you would probe them, right? But we have to, but because of time, I'm not going to, because I already know the path to compromise the system. Now, remember I said we usually do sudo-l to list the sudo-l actually tells us the privileges or the sudo rights that particular user has, right? So over here, we are seeing Xander, right, can actually execute user bin user management, right, without a password. That is basically what this line is telling us, right? So he can do sudo, then let me copy this. So you can do run this without any password, right? And with sudo privileges. So when we do that, we realize, okay, it's some sort of a script, right? So I'm seeing it has options. Backup projects, backup MySQL data, and then reset admin password. So let's try this one and see what it does. So it looks like it's backing up some sort of a project, right? creating archive in var backup projects.zip. All right. Okay, let it run. So now we know it creates a backup. So you will want to exit out of this. And then at least check to see if it's a text file we can actually read, or maybe it's an executable. Whether it's, I mean, let's say, whether it's a normal text file, right? Or an executable, the file command will show us that. Now, if we do file on that particular file, right, you realize it's an L file. That is a Linux executable. So in Windows, we have .exe. In, what is it called? In Windows, we have .exe. In Linux, that's an L file for you, right? That's the particular format for Linux executables. Now, so if we do cut here, it's going to show us gibberish, right? It's going to show us gibberish because it's an executable. So I'm going to type reset to fix my terminal. Then use strings. Now, the strings command allows us to, let's say, get, how do I say, how do I put this? So you can think of it as a readable characters from an executable. So if you have maybe an executable, and that executable probably contains maybe a message like type your password or whatever. If we do strings on that executable, strings can actually print out that statement. So if I do strings on the particular file, right, it's listing out all the readable content. So you see, we have reset admin password. That was a part of the prompt, right? That was listed. So we see that these files are these things you are seeing here are all part of the executable, right? Which we do not actually care about, right? We can keep scrolling and realize, okay, over here we have something interesting. We see it's using user bin 7-zip, right? So 7-zip A is just like 7-zip, right? The 7-zip executable, and it's doing a -A. It's creating, okay, the file it's going to back up and using these flags, right? Now, this is the executable. This is the compression software this script is using, right? And you can see over here too, we saw is it backup database. It's also using MySQL dump -A, right? And then specifying the path to back the database up, right? Now, we want to find a way to abuse this particular script because, well, Xander can run it as root, right? And if we're able to exploit this application, we will gain root access because, well, we are able to execute it as the user root, right? So what attackers usually do is, because the script is running 7-zip and probably MySQL dump, we'll probably see if we can identify maybe ways to abuse 7-zip, right? To get root access. So visit our browser or this invisible thing. Let me just, okay. So we visit our browser, then search for example, okay, 7-zip A, right? So 7-zip A exploit, right? Now the first link that comes up is from Hacktricks. Whenever we see Hacktricks, we are happy because, well, they always have good news. So we access that link, and then, well, you are not working with Changeon or Chmod, not tar. Tar is also a compression software, rsync, saying. Now here we have 7-zip, right? Now, in here, it's saying something in here, and we know from here, from here, this here is similar to what we have here, right? So, well, this is actually interesting. So we'll read to see how to actually maybe exploit or abuse this. Now it's saying when 7-zip uses the -- before this, right? It means that every, what is it called, input or everything else in that directory is going to be treated as a file, right? That's what it's saying. This whole thing is saying here. Now, it is also saying if we create a file, right, in the folder where it is being executed, we can create, so for example, you can create the file maybe at root.txt and the file root.txt being a symlink. So we are going to create a symlink pointing to root.txt. So I'll explain what a symlink is. So this is what it's telling us to do. So it's telling us to touch at root.txt, then create a symlink to the file we want to read, then create a file called root.txt. So let's do that. I'll explain further. Now, when I was doing this, I actually suffered a bit because I thought because if I do this, sudo dash the file, right, we are executing in our home directory. So obviously, well, so obviously I have to create those files in here. But now, if we scroll back up to here, right, there's an error message here saying error changing working directory to what? var www.html, right? Now, this over here, we are certain will only happen if should the application fail to what? Change directory to the var www.html. So we are certain it's changing directory to that directory, right? So var www.html, right? So that particular 7-zip command is running inside here. So here. So this is where we have to create the files for the exploit. So over here, because SSH is running, right, the file I want to read is roots, the root user's SSH private key, right? So what I'll do is touch, following the instructions here, right? So he's doing touch root.txt. So I'll do touch id.rsa, right? Because that's the file I want to get. Now here, it's saying we create a symlink to the file we want to read. Now the symlink's parameter is ln-s, right? Then I know the private key for the root user is always in the root directory /id.rsa, right? And then it's saying we link that to id_rsa like this. So we do ls here. So we do ls and realize, let me do it this way. Realize, okay, so we've actually created these two files, this and this, right? Now, someone might ask what a symlink actually is. So let me go back to my own terminal prompt, right? So this is my local system, right? I'll access desktop. Let me remove hello.cpp from here, right? So, okay, this is my home directory, right? Let's create a file in here called BT session, right? Now, BT session is a file, right? We can write anything to the file. Let's echo Rashid into that file. So if I cut BT session, right, it contains Rashid, right? Now, what I'm going to do is move BT session to my desktop. Right? Right, so it's no longer here, but on my desktop. So if I do ls desktop, ls desktop, you see the BT session file here, right? Now, basically what a symlink is, let me create one and explain what it does. So ln-s, then where the symlink is. So I'm going to specify the absolute path to it. Then, so it's in desktop.bts.session, right? Now I can give the symlink any name. So I'm going to do it maybe hello world, right? Hello world, right? So if I do ls-l here, right? We have, I have real symlink here. Let me take this off, right? So if I do ls-l here, right? You see, we have hello world here, and it's actually what? Pointing to home/snipe desktop and then BT session. Now, if I cut the new file, the symlink, realize it contains the content of what? BT session, right? Now, if I echo, let's say I echo any message, right? into the hello world file we just created, which is a symlink, right? And if I cut that, you realize, okay, that message is in here. And if I cut the BT session file on the desktop, you realize it contains the content of, what's it called? It contains the updated content, right? So when you create a symlink, right, it's like you're creating a replica of the same file or folder directory, and anything you do in one will be replicated in the other, right? So this symlink we've created here, it's going to, so if we had access to the root directory, right, this file we've created, let me cut the ID RSA we've created, this symlink would contain the what? ID RSA of the root user, because we are pointing to that. We currently do not have what? Permission to what? Read that. But the 7-zip command actually has that permission. So if we do the sudo, oh, where is it? I think it's no longer my clipboard. So if we do this, the sudo, oh, and then execute this command, right? Per what is here, right? This instruction. Let's, in fact, what is even here isn't self-explanatory. The best, we can use our best friend here, then ChatGPT, right? ChatGPT is very intelligent, most intelligent best friend. So what we can do here is just say, paste this in, right? And then say, explain this. Right? Looks like it's thinking. No, ChatGPT. Spit of a lot of stuff. Okay, sorry. So if we read this, right, ChatGPT explains what all these parameters are and why this is actually vulnerable. It doesn't tell you why it's vulnerable, but if we read this, we will actually deduce where the vulnerability lies. The vulnerability lies in the fact that it's over here. Let's read. So this option, right? Where is it? Oh, where is it? Where is it? Where is it? So this option, language. Oh, well. No. Oh. It should have been this particular file. This option language should take. Well, it's actually not giving me what it gave me earlier, but it will tell you this option actually, how do I say, reads symlink. So when it sees a symlink, it's actually going to read that particular file, right? It's like what that symlink is connected to. Well, it's showing us a different thing, right? So if I execute this here and select the backup, the project backup now, it's supposed to read the symlink. Well, it's not reading it. Let's see. Let it go. But if you have any question, kindly let me know. Right? I'll go back and then explain. What's happening? Well, if it worked, I've seen the output now, but I think it isn't. No. Okay. Cut ID RSA. I know it didn't work. All right, let's list the content again. All right, for some reason, we do not have the ID-RSA. This thing we created has vanished. So let me create it again and then run the command. Okay, it worked. Now I'll just cancel out of the script and realize we have the ID RSA for the root user here, right? Now it contains some weird string, so I'm going to at least copy it over and then tidy it up on my machine. So I'll create maybe. Now, whenever you see me doing, so what I just did was Control-BZ to make this small pane big, right? So it's still there. So just vim, let's do it temp, right? We want to edit this. So I want to take out this, I want to take out this. Okay, yeah, so I'm just taking out, oh, sorry. Let's go here, clean. Clean. Well, I can't see the top because of the invisible bar here. All right, so there's one at the top. What just happened? Oh, sorry. There's an invisible bar disturbing. So, okay, it looks perfect now. So I'm going to cut temp, copy it over to my clipboard, right? I'm going back here, then I'm going back to Zendesk home directory. I can do it here, but I want at least a clear space, right? So I'll do vi then id.rsa, right? Now I'm going to paste the content here from BTT, ZSH clipboard, then save. Right, so ls-l, we have the ID RSA here. Now the SSH client, right, always wants you to provide it needs the particular set of permissions to be able to read the, what's it called, read and execute the ID RSA private key. And that particular set of permission is the 600. I'll explain what the 600 is. So I just do chmod 600. So let me do ls-la again. Now I realized previously, right, the execution bits for the ID RSA was read write for the owner, read write again for the group it belongs to, and then read for others. But the SSH client prefers or wants just the read write bits of the owner set. Any other bit set, it will start screaming, it will scream. So we just do this to prevent it from screaming, the changing of the bits, right? So now, because we have root private key, we can at least try to SSH using that. So we do SSH-I. I is a flag to specify the ID RSA or the private key. Then now we want to SSH into root, then via localhost, right? So we just accept. Well, what just happened? Localhost and the load key RSA error. But I think we have some sort of error coming. Give me a sec. Let me vim ID RSA. I don't know if I made a mistake editing this, which I don't think I did. Let's try one more time. So SSH-I, ID RSA, root, then localhost. So it's requesting for a password, load key ID error in lib crypto. Really? Okay, so let me go back to where we were, and then we get the ID, the public key again. I'm sure I messed it up. If I didn't, then there's a problem with the box. Right, so ls-l. Let's touch this ID underscore RSA, right? Let's execute the sudo-l. I need sudo this. Before that, let me list this thing again. It usually disappears. Okay, so sudo this. All right. So cancel the output again. Now, did I miss something? Well, I don't think I did. Is M equal to DS Q MI ZW, right? Yes. So I know I didn't know this up, but let me just open this guy and see. Nope, I didn't. So I think, let me do this again. All right, so if this box is misbehaving, let's do it from our machine, right? So cut temp, right? Let's move temp to ID. If it's a problem with the box, I should think this will work. So ID RSA change mode to 600, then ID RSA. So sudo-l, sorry, SSH-I. Whoa, looks like I don't have SSH installed in the container. This is bad. SSH. So let me just do install pkg. This is React pkg. SSH. It's supposed to be SSHD, right? Wow. That was embarrassing. Search, give me a sec, search pkg, SSH. Oh, okay, open SSH, my bad. Install pkg, open SSH, right, yeah. So yeah, it down to SSH-I, then ID RSA, root at that particular IP. Yes. Okay, then we are finally root. So I guess SSH within the box is actually broken. So
I think
ID, yeah,
I think when you pasted the file in the box, right? The
yeah,
very like see those dashes that come before the begin open SSH key. They
yeah.
come as like they
Oh,
are
really?
not current in that file. Yeah, so you can read it. Let's see.
All right, let me check. So cut ID RSA. Oh, okay, that's true.
Ah.
That's true. We are missing something. Okay. All right. So if we fix this and run it, we'll also gain root via the box. All right. Nice catch, Maxwell. All right, so that brings us to the end of this session. So ID, we are root. Who am I? We are root. We do ls, we have access to the root.txt file, and we can paste that in unhack the box to complete the box. That brings us to the end of this session.
Well, that's wonderful.